What's up? I'm Vin, and today I want to go through the STAAR Algebra 1 exam from May 2022. I'll leave a link to a copy of this test in the description below. Now let's get started. So first up, we have a graph of a quadratic function r. It's shown on this grid, and we want to know which answer choice best represents the intercepts of the graph of r. So we have the x and y intercepts. Now just looking at this, I can see right away that we have an x-intercept at -10, and we have another x-intercept at x equals +2. Just know intercept is kind of like intersection point. So the x intersection points I think of is where the graph crosses the x-axis. And then the y-intercepts is where the graph crosses the y-axis. And if we look over here, we could see that the graph is crossing the y-axis at -5. Right between this number here is -4 and this number here is -6. So at -5. So we have x-intercepts of, we have -10 and 2, but it's written as a pair of points here. So this would be the point -10, 0, and this would be the point 2, 0. And then down here at -5, that y-intercept we would express as 0, -5. So now we scan the answer choices here. So we have x-intercepts at -10, 0, 2, 0, and we have a y-intercept at 0, -5. So choice D would be our answer. So question 2, we have a little bit to read here. We have a worker is packing items in boxes, and the table shows the linear relationship. Okay, so that's the $1,000,000 phrase right here. Linear relationship means that the pair of quantities here are going up at a constant rate. So we have between the number of items the worker has packed in boxes after different amounts of time. So that's the first thing that's jumping out at me right away, is the linear relationship says everything. But which statement describes the rate of change of the number of items the worker packed in boxes with respect to the number of minutes the worker has worked packing items in boxes? So we're looking for, once again, the relationship between the number of items packed with respect to the number of minutes. So this is in a sense acting like our y-axis, and this is acting as our x-axis. So if we look here, that would mean that the ratio here, 20/5, and it's 20 items in 5 minutes. And this would reduce 20 divided by 5 is 4, so it'd be 4 items per minute. So this is the rate here. And if you want to check any of the other columns here, or any of the other rows here, let's say you pick this row. So that would be, let's make that a little bit neater. So that would be 44 items in 11 minutes. If you look at what we have, like the label here is items. So we have 44 items, and that's going on in 11 minutes. And if we did 44 divided by 11, that would also give us 4 items per minute. Okay, so the rate is constant because, once again, it's a linear relationship. So now we just scan the answer choices, and this is going to match up with choice H. So question 3, we have a system of equations graphed on the grid, and we want to know which system of equations is best represented by the graph. So this is the equation that you need, y equals mx plus b. The number in front of x, the m value, is the slope. That is the rate of change of the line. It tells you how fast the line goes up or down. And then the b value is the y-intercept. That tells you where the line crosses the y-axis. So let's say I take a look at this line here. So this line here crosses the y-axis at -3. So the b value for that line would be -3. And then to find the slope, I just have to pick 2 points. And I already have 1 point here at the y-intercept. But the next point I could focus on would be over here at 5, -1. So now this is the point at -3 here. This is technically the point 0, -3. So what I could do is use the slope formula. I could say y2 minus y1 over x2 minus x1. But when you have a graph and the points are nice, you could just count the rise over the run, because the slope tells you the rise over the run. This is very useful for graphs. So here, if I rise to get from this point to this point, I have to go up 2 units. So my slope, I would be going up 2 units, and then I'm going over 1, 2, 3, 4, 5 units. So my run would be 5 units. So this would be my slope, 2/5. And my line, if I use the mx plus b formula, I would have m is 2/5 times x, and then plus b is -3. And if I write plus -3, that's the same thing as just tacking on a -3. And then once I have one equation here, notice this eliminates every answer choice, because 2/5 x, the y-intercept is wrong for this, so A is out. For B, notice we have 2/5 x minus 3, but we would need to verify this one. Okay, we have to make sure that the second line has this equation. So then what we have for choice C here is that is not even showing up at all, so that's out. And same thing for choice D, that this is out. Now, if we want to be 100% safe here, notice the second line has a y-intercept at -8. So the b value for the second line is -8. And then if I pick out another point that's on this line here, And we could cheat a little bit here. We know that we should be getting a slope of -3/5, which means we'd have to go down 3 and go to the right 5. But if I want to reverse that, instead of going down 3 to the right 5, I could go up 1, 2, 3, and to the left 1, 2, 3, 4, 5. And notice that gives me another point here. So my rise over run would be -3/5. So I would have an m value here of -3/5. If you want to practice using the slope formula, what you could do is just identify the coordinates. This is the point -5, and this looks like, -5, -5. So that's the point of intersection here. And if I wanted to, this is the point 0, -8. We could use the slope formula. So I could say m equals, and then what I'm doing here is I'm calling this, let's say, x1, y1, and I'm calling this point x2, y2. And if I find the slope between them, I would do -8 minus -5 over, and then x2 minus x1, I would have 0 minus -5. And this would give me m equals -8. This turns to +5 because I'm doing minus minus. And -8 plus 5 would give me -3. And then 0 minus -5 changes to +5. So notice that I do get that slope of -3/5. So if you want to use this formula, you can. But in any case, you're going to get choice B. Question 4, which graph represents y as a function of x? So to test if this is a function of x, we could use the vertical line test. Okay, and the way that this test works, the vertical line test, is if you draw a vertical line through the graph at any location, if it hits the graph more than once, like let's say choice H, that notice we hit the graph at 3 locations. Right away, I could see this is not a function of x. If I draw a vertical line here, and I can make that a little bit neater, let's say I draw it at x equals 6. So I draw a vertical line here, it's going to hit the graph at 2 locations. So choice F is out. This is also out. Let's say I drew a line at x equals -6. Notice it's hitting the graph at 2 locations like this, so it's out. And now this graph here, no matter where I draw a vertical line, it's only going to touch the graph at 1 location, no matter where I draw that vertical line. So choice J would be our answer. Question 5, we want to know what is the solution to the system of equations, and we could solve this by using elimination. So what I'm going to do is I'm going to multiply everything in the top equation by 2. And the reason I'm doing this, I'm going to have 2 times 2x is 4x, and we're going to have 2 times y is 2y. And the reason why I did this, now we have 2 times 40 is 80, but the reason I chose to multiply the top one by 2 is notice when we rewrite the bottom one, that the y variables have matching coefficients with an opposite sign in front. So now what I could do is I could add these equations together, and I would have 4x plus x is 5x. 2y plus -2y is 0. This just cancels out. It eliminates. That's why we call it the elimination method. And then this would be equal to 60. So now divide both sides by 5. And this will tell you here that x is equal to 12. So then what you're going to do with this information, you're going to plug it back into any one of the originals, and it should tell you the answer. So we have 2 times, and then x is equal to 12, plus y is equal to 40. And now this is going to give us 24 plus y is equal to 40. Subtract 24 on both sides, and you're going to have y equals 16 after this cancels out. So our solution looks like it's 12/16, but then just to be safe, I would plug into the next equation here. And if we did x equals 12 minus 2 times y we found to be 16, this should equal -20. And this gives us 12 minus 32 equals -20. And then 12 minus 32 is in fact -20. So I feel very confident A is our answer. Now, if you have a TI 84 plus CE, another thing you could do, and this should be illegal because it's so easy, but what you do is you go to number 9 here, polynomial simultaneous, and then it has a little 2 after it like this. So we're going to go to this one, and we're going to do a simultaneous equation solver. So that's a fancy way of saying system of equations. And we're going to do it 2 by 2. We have 2 equations and 2 unknown variables. And now I'm going to press the graph button because that's going to select next. And now we just type in our equations. We have 2x plus, so I'm going to hit enter just to keep this as a plus, 1y, so I'm going to actually write a 1 here, and that's equal to 40. And then we go to the next equation here, it's 1x, and there's 2 ways I could do this. I could write minus 2y, or I could write plus and then put a -2 in front of the y. And now I write my -20 like this. I hit enter. Now that my equation is all good to go, I press graph here to solve it. And notice we get 12/16 with no work done. Okay, so once again, that probably should be illegal, but hey, if you're allowed to use a calculator like that for the test, why go through all this pain and suffering? Just use the calculator. You could also get choice A. Question 6, which graph best represents a quadratic function with a range of all real numbers greater than or equal to 3. So one thing you need to know right away is that range represents the set of all y values. Okay, so this represents the y values of the function, and we need the y values to all be greater than or equal to 3. So let's look at choice F. Choice F right away I could see is no good because here the maximum y value occurs at -3. So this would be the correct answer if they said a range of all real numbers less than or equal to -3, because you could see all of the y values on this graph are going under -3. So if we look, and we're focusing on the y-axis here, you could see that the highest point occurs at -3. So think of that as like kind of like a ceiling in this case. So this is like a maximum value, and our maximum value is -3. So all of our y values would be less than or equal to -3. And now looking at h is almost good, except for this quadratic, all of the y values would be greater than or equal to -3. So you see here, this acts almost like a floor, and this one here acts as a ceiling. So if we want our y values to be greater than or equal to something, that means we need a floor in our situation here. So h we could eliminate, g we could also eliminate because this would be a set of all y values that are less than or equal to +3. So this is acting as a ceiling. So this is no good. So just by default, it has to be j. But if you look at the graph here, see that the minimum value occurs at y equals 3. And this is acting as a floor. This is the bottom of the graph. So every point here is going to be going above y equals 3. And there is a location where the graph is equal to 3, and that's at the vertex. So this is definitely our solution. Question 7, the value of y is directly proportional to the value of x. And we have when x is 512, y is 128. What is the value of y when x equals 64? So for this question, anytime I hear y is directly proportional to x, I think of this equation here, y equals kx. That's the formula, and k represents the constant of proportionality. But I'll just write it's our constant here. So what we do here is we plug in x and y. So we have y is 128, and this is equal to k times x is equal to 512. So anytime they give you a pair of values here, this helps you find the value of k, our constant. So I would just divide both sides by 512, and that's going to get the k term by itself. So now we can just do the division here. We're going to do 128 divided by 512. And hopefully we get a nice decimal here, and we do. This simplifies to 0.25, or if you don't know that that's 1/4, you could press math, enter, and that'll tell you k is equal to 1/4. So we have k is equal to 1/4. And now what we do with this information, we're going to plug that back into y equals kx. So now we have y equals 1/4 x. So now what is the value of y when x is 64? We're going to plug in x equals 64, and we'll have 1/4 times 64. And if we do the multiplication here, 1/4 times 64, or you could say 64 divided by 4 is 16. So choice C is our answer. Take a moment to read through question 8. Now, the only part of this question that truly matters is 8x plus 5y is less than or equal to 100. And they're telling us x represents the number of bath towels, y is the number of hand towels, and we need to know which graph best represents the solution set for this inequality. And they label everything for us. So really what you're doing here is just think of this formula again, y equals mx plus b. And for this one, I would solve for y. So I would take this, I'll write it over here. We have 8x plus 5y is less than or equal to 100. And the first thing I would do is subtract 8x on both sides. So that's the first thing I'm doing. And I'll write the result over here. We would have 5y is less than or equal to negative 8x. And then we have plus 100. So now divide everything by 5. And what we have here, we have y is less than or equal to, we have negative 8/5 x plus 100 divided by 5 is 20. So notice every single answer choice here, the y-intercept is 20. So that's not going to be helpful here, but what will be helpful is the slope and the inequality sign. So the slope here is negative 8/5, which tells us that the line should be going down 8 units and over 5 units. So let's say I look here. I'm at the point, so this is at the point here at 0.20. So I'm going down 8 units. So I'm going down, if I go down 8 units from 20, that brings me to 12. And then I go over 5, that should bring me out over here like this. And that should bring me to the point 512. But notice every single graph has 512. So it looks like here the slope is not even the defining piece here. So what the defining piece of the question is is understanding this inequality sign. That says less than, so this is less than or equal to. Now, the fact that it has an equal to attached, it's not just a less than, it's a less than or equal to, means that the line is solid. So this means, so this is really important, it's solid and we shade below. Okay, so the equal to tells you solid line, and the less than tells you why less than tells you to shade below. So looking at this, F is out because it's not a solid line, J is out because it's not solid, and then H is out because they shaded above. So choice G would have to be our solution. Question 9, we have an exponential function graphed on the grid, and we want to know which function is best represented by the graph. Now for this one, I'm thinking of a few things. So this I don't even need a calculator to do, but I'm thinking of exponential functions, which are in the form of y equals a to the x power, where a is some real number. And you can see every answer choice is in that form. But I know something like, let's say, choice C and choice D right away are not correct, because they're in the form of we have a number to the x power, but the base here, in this case 1.25, is greater than 1. So anytime you have an exponential function in this form and the base is greater than 1, that's going to give you exponential growth. But if I had a different situation like choices A and B, anytime my base, so I'm thinking once again, I have y equals a to the x. If my base A is between 0 and 1, like let's say choice A, if I have something like y equals 0.25 to the x, I know this is going to be exponential decay. But now, how do we know which one is the correct answer? Well, what we could do here is we could pick out a random point, like let's say the point -1,4. So I look at something like this at -1,4. I could even look at the y-intercept. The y-intercept is here at 0, 1. So if I want to do this without a calculator, I could see right now that choice B is wrong, because if I plugged in 0, p of 0 would be 2 times 0.5 to the 0 power. And if I raise 0.5 to the 0 power, that's equal to 1. So I'd have 2 times 1, which is equal to 2, which would tell me that my y-intercept should be 2, not 1. So that's how I know B is eliminated, and A would definitely be correct. Now, if we want to verify that A is correct, we could go to the y equals here, and we could write in, we have parentheses 0.25. We close the parentheses and go to the x power. So I'm going to press this up arrow here, and then type in our x, which is over here. And now if I press graph, notice that I get an exponential decay like we need. But if I want to see that my points are good, I press second graph here. And let's see if our points check out. So we had 0, 1, and we had the point -1,4. So choice A is definitely correct. Question 10, we have to know how to multiply two binomials together. So we're going to expand this using the distributive property. You could, if you've heard of FOIL before, you can use FOIL, but I just like to call this distribution because that's technically what it is. So we have n times 2n is 2n squared, and then I'm doing n times 7, and that's going to give us 7 times n, or 7n. And then we have to distribute the -4, so we're going to do -4 times 2n, which is going to give us, we're going to do -4 times 2 is -8, and the n just tags along. And then we have -4 times 7, which is going to give us -28. And now once we get to this step here, we want to combine these two like terms. So this is going to be 2n squared, and then I'm just thinking 7 minus 8 is -1. So I'd have -1 times n, or I could just say minus n, and then the -28 just tags along. And now we scan the answer choices, and this is going to match choice J. Now, another thing we could do here is we could type in the question in this form, and we could type in all 4 answer choices. Now, if we did this correctly, the question is in blue, and the correct answer choice here, 2n squared minus n minus 28, corresponds to y5, which we had in green. So the blue and green graphs should completely overlap here. So if we press graph, notice we got the blue graph, and then the green one completely covers it. Another way to see this here, we go to the table, we press second graph, and if we look, y1, we have -25, -28, -27, and so far nothing matches it except when we get to y5, -25, -28, -27, the values do in fact match. So this is definitely the correct answer choice. Question 11, which situation shows causation? Now this we could solve with just common sense. So causation means that one thing is definitely going to make the other thing happen. So let's look at A. When the number of people in a bus increase, the number of animals in a zoo also increases. All right, so this one here just sounds completely ridiculous. Like, as much as I like zoos, I just don't see here how a bus here, unless it's a magic bus, but people going on a bus is just going to magically make animals appear. So this is just, yeah, kind of ridiculous. So A is out. So B, when the number of hours worked each week by an hourly employee decreases, the amount of money earned by the employee also decreases. Yes, this one is right away sounding very reasonable here because it's very simple. If you want to make money, you have to work and they will pay you the hours. Okay, so this is an hourly employee. This is not a salaried employee. This is an hourly employee, which means they only get paid by the hours they work. So if you don't work the hours, they're not going to pay you for the hours. So B is definitely looking good. But let's see why the other choices are no good. When the amount of a discount for a sale increases. Okay, so when the amount of a discount for a sale increases, the number of items sold during the sale decreases. So this one here is just not making a whole lot of sense. But when I think about this one, when the amount of a discount for a sale increases, so they increase the discount. So instead of like, let's say 20% off, you get 50% off. The number of items sold during the sale decreases. Well, having a sale is not necessarily going to have an effect on anything. Like, let's say, I don't know, they're selling acorns. Like maybe like no one's really interested in buying acorns. It's like, all right, I'll sell you these acorns for $100. No, I don't want your acorns. All right, how about I give you 50% off? Like, no, I still don't want your acorns. So like, there's no change. So this one here is just kind of silly. So it's out. And then we have when the number of bike trails in a city decreases, the amount of rainfall in the city increases. No, bike trails has no effect on rain. So that one is also silly. Choice B is our answer. So take a second to read through question 12. So we have a system of equations and line H is given to us in a table of values and line J we have an actual graph of. So for this one, I'll start with line J. We have the formula y equals mx plus b, where once again, m is the slope and b is the y-intercept. So I just need to identify what is our m and b value. So our b value is easiest. That's the y-intercept. That's where the graph crosses the y-axis. And it crosses at y equals 1. So we have a b value of 1. And now our slope, we could say, is our rise over run. Okay, since we have a graph, it's going to be easy to count the boxes. So what is my rise over run? So I have to go to get to, let's say, this point to this point, I'm going to go down 1, 2, 3, 4, 5. So I'm going down 5, and I'm going over 1, 2, 3, 4. Okay, so that would be my rise over run. And if I want to check this, I go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. And that brings me to the next point. So now just write the equation. We have negative 5/4 x, and then we tack on our plus 1 for our y-intercept. So now if we scan the answer choices, the only answer choice that has negative 5/4 x plus 1 is choice J. But then how do we know that line H is negative 3/4 x minus 5? So we could just type everything in the calculator. We're going to press stats, and we're going to go over here to edit, and we're just going to input this data from the table into this table over here. So everything in the X row, I'm going to put in L1, and everything in the Y row is going in L2. And now once we have all the data in, we're going to press stats. We're going to go over to calculate. So we're going to press the right arrow. And then we need a linear regression because we want the equation of a line. So I'm pressing number 4, and I'm going to keep pressing enter till we get to calculate. And this gives us all the information we need. So now we just write everything out. We have y equals the a value, the coefficient of x, that's our slope, is negative 0.75, which is the same thing as negative 3/4. So that would be negative 3/4. We tack on the x, and our b value is minus 5. And notice how this does match our answer choice. So this is definitely correct. Question 13, which answer choice describes how the graph of f of x equals x squared was transformed to create the graph of n of x is x squared minus 1? Now, I know right away x squared, if I put the minus 1 after the function, that's going to shift it 1 unit down. So a vertical shift down would be our correct answer choice. If I wanted a vertical shift up, let's say I write the new function, I'll call it g of x. That would be something like x squared plus 1. So that's why I know a is no good. A horizontal shift to the left, let's say I call this h of x. That would be, if I want to go to the left, I would write, let's say, x plus 1 squared. I know it seems counterintuitive. You would think x plus 1 would send you to the right 1 unit, but this actually sends you to the left 1 unit. And then choice D, a horizontal shift to the right. I know that this is no good because that would be, let's say, something like w of x. And if I wanted to go to the right 1 unit, I would have x minus 1 squared. So that would be our solution, choice C. Now, if you want to be 100% sure, just go ahead and type in, we have x squared, and then we type in the n of x function, x squared minus 1. And if we graph both of those two equations simultaneously here, Remember, the original equation was x squared, which is in blue. The red one should be shifting the blue one down 1 unit. And notice that the red one is going 1 unit under the blue one. So choice C is definitely correct. Question 14, we have this quadratic expression here, and it could be written in factored form as d plus 2 times d plus k, where k represents a number. We want to know what is the value of k. So for this one here, we have d squared minus d minus 6. We need to find two numbers that have a sum of -1, and the two numbers also need to have a product of -6. Now, just know, in case this isn't obvious, the reason I'm saying -1 is because the invisible number in front of d, if it's not written there, is 1. So the coefficient of d would be -1 in this case. So that's the technique for finding the factors of this quadratic expression. So the math that you have to be able to do in your head for something like this is you have to think of all the factors of -6 in pairs. So I could have something like, let's say, 1 times -6. I could also have -1 times 6. That would multiply to -6. And then I could also have something like, let's say, 2 times -3. Or I could have -2 times +3 like this. So then what I need to check, though, in order to find the perfect pair that matches this situation, is I have to find the sum of each of those factors. So I would do, let's say, 1 plus -6. And that would give me -5, which does not match the -1 that's in front of the term d here. So this pair is out. And then I would check the next one. If I have -1 plus 6, that would give me +5. So this pair here is no good. And now we move on to the next pair. If I did 2 plus -3, notice this gives me -1, which is what we want. So this would be the correct pair. And then just to verify the last one here, -2 plus 3 would give me +1. So that's why -2 and 3 are no good. So now I'm able to factor this. This is going to factor to d plus 2 times we have d minus 3. So we just write the two numbers that we were thinking of, the two factors, and we write them in the parentheses here like this. So now we want to know, what is the value of k? Well, notice we have d plus 2, and then we have d plus k, and then we have d minus 3. So this tells us here the value of plus k, or just k, is going to match up with -3. So here's our value of k. Question 15, we have a graph of a linear function, and we want to know which equation is best represented by the graph. So just think y equals mx plus b. This is our golden formula. M is the slope, and b is the y-intercept. So that's probably the easier piece to identify right away. The y-intercept is where the graph crosses the y-axis, and this is happening between 6 and 8. So the y-intercept here would be 7. And now if we look at the x-intercept, notice that it's crossing the x-axis at 4. So that's going to help us find the slope in a moment, because the slope we could think of as the rise over the run. Now, you could use this formula to find slope, but anytime you have a graph, the graph, it's usually just easier to find the rise over the run. It's going to save you a little bit of time. So how do I get from this red point to this red point? I would have to go down 7. So my slope would be, I would have -7, because I'm rising -7. I'm going down 7, and I'm going over 4. So that would be my slope. So I have my m value, and my b value here, my y-intercept is at 7. So that's my b value. And now I just plug m and b into the equation. We'll have y equals, our slope m is -7/4. We tack on the x, and then our b value is, we're going to have +7 here like this. So now just scan the answer choices, and this is going to match up with choice B. Question 16, you want to know your law of exponents. So if you have something like a to the b and you raise it to the c power, this is going to be equal to a to the b times c. The next one you should know is if you have a to the b times a to the c, that's going to give you a to the b plus c. And then the last one, if you have a to the b divided by a to the c, that could simplify to a to the b minus c. So looking at this, the first thing that jumps out at me is we have d to the 6 to the 3rd. So I would use this first rule here. And the first thing I would write is we have c to the 8 times, and if I do d to the 6 to the 3rd, I'm going to multiply 6 times 3, and that's going to give me 18. And then we're dividing by, we have c to the 2nd. So now I'm focusing on c to the 8 divided by c to the 2nd, and that's making me think of this rule here. So if I want to simplify this, I'm going to do c to the 8 minus 2, and then the d to the 18 just tags along. And now this is going to simplify to, we're going to have c to the 6, because we're doing 8 minus 2, and then we have d to the 18th power. So scan the answer choices. This is going to match up with choice J. Now, question 17, one of the nice things about multiple choice is you could just plug in answers. We want to know which value of x is the solution to this equation. Now, this would be a solution to the equation if we plug in that x value and it keeps the equal sign true. So I'm going to plug in x equals 3. We have 5 times, instead of x to the 2nd, we have x equals 3 to the 2nd. And now we're going to say this is equal to 30 times 3, and then minus 45. So now this one here, we have 5 times 3 to the second is 9. So I have 5 times 9 equals 30 times 3 is 90 minus 45. And if you work this out, 5 times 9 is 45. And 90 minus 45 is also 45. So x equals 3 is definitely our answer here. But let's say I want to do this a more technical way. Let's say this wasn't multiple choice and we wanted to find our solutions. Well, what I would do is I would start with, we have 5x to the second, and we have, this is equal to 30x minus 45. I would move everything to the left side because when you're solving a quadratic equation, you need the right side to be equal to 0, or at least you need one of the sides to be equal to 0. So you move everything to one side. So we have 5x squared now minus 30x. And now on the right side, 30x minus 30x canceled. So we're just left with minus 45. And now add 45 to both sides. And now this is going to bring us to the next line. This is going to cancel minus 45 plus 45. And we have 5x squared. We're going to have minus 30x. We have plus 45. And now this is equal to 0. So at this step, I would factor out a greatest common factor. So I'm going to take out a 5, and we're going to have x squared minus, and if I do 30x divided by 5, that's 6x, plus if I do 45 divided by 5, that would be equal to 9. And then I close the parentheses and set this whole equal to 0. If I want to see if I factored correctly, I could always distribute that 5 all the way through, and it should bring me back to the previous line like this. So now we're playing that add multiply game again, but this time I need two numbers that have a sum of -6, and the two numbers need to have a product. We'll abbreviate here. We need to have a product of 9. So I'm thinking about this, and the two numbers that come to mind are -3 and -3. If I multiply them, I get +9. If I add those two numbers together, I'm going to get -6. So I would 5 times, and I have x minus 3 equal to 0. Now, when you're solving a quadratic equation, you need to set each factor equal to 0, but don't set the constant equal to 0, because if you say 5 equals 0, that's just a silly statement, which you could just quickly cross out. So you just set the things with the x's equal to 0. So I would set x minus 3 equal to 0. And that's true when x is equal to 3, which right away matches choice A. You don't need to set x minus 3 equal to 0 again because you already did it. This would give you the same solution of x equals 3. So A is our answer. Question 18, we have a florist making bouquets of flowers for a wedding, and each bouquet will have 9 flowers. The graph shows the linear relationship between y, which is the number of flowers used, and x, the number of bouquets. And the florist will use no more than 8 bouquets for the wedding. So this is a really important piece of information. Which set best represents the domain, that's the $1 million phrase right there, of the function for the situation. Just know domain refers to the possible x values. So that's what we need to be focusing on here. And now just think about it. X is the number of bouquets. So they told us here the florist will use no more than 8 bouquets for the wedding. So now combine all of this. X is the number of bouquets. Domain is the possible x values. The florist will use no more than 8 bouquets for the wedding. So if we look here, we need a set that has all the numbers, the positive, 0 included, because I guess somebody could get no bouquets, but they're going to get no more than 8. So we need the numbers from 0 to 8, which right away I could see corresponds to choice G. The problem with F is that it's not including the odd numbers like 1, 3, 5, 7, 9. There's nothing wrong with someone getting 5 bouquets. You could see here at, let's say, 5 bouquets, the person would have 5 times 9, which is 45 flowers altogether at their wedding. So that's why this choice is no good. H is no good because it looks like here they're counting by 18s. So they're skipping this middle stuff here in between the grids at, let's say, 9 and over here at, let's say, 27. So this is referring to the range, but it's only counting by 18s. And then J is like a tempting answer choice, but it's a very dangerous bear trap. So the problem with J would be which set best represents the range of the function for this situation. So this one you just have to read carefully and make sure you're on the lookout for that key vocabulary. So this answer choice here, choice G is our best option. So question 19, we have a line here and we want to know what is the rate of change of y with respect to x for this line. So for this one here, I would just find the coordinates. We have the point -3, 5. So this is -3, 5. And this point over here looks like we're at 9 and then going down 5. So 9, -5. So we have 9, -5. And then I'll call this x1, y1. And I'll call the next point x2, y2. And now our slope formula, we have y2 minus y1 over, we have x2 minus x1. So then just plug in, we have m equals, and we're going to do y2 minus y1. So we have -5 minus 5 over x2 is 9 minus x1, is negative 3. So now this is going to work out to, we're going to have negative 5 minus 5 is negative 10. Over, this changes to 9 plus 3 because we have a double minus, and that's going to give us 12. And now this one here we could reduce by dividing the top and bottom by 2, and that's going to simplify to negative 5 on top over 6. So negative 5/6, choice D is our answer. Question 20, what is the value of the y-intercept of the graph of h of x equals, and we have this function here. So anytime I'm looking for a y-intercept, the first thing that comes to mind is that any y-intercept you could think of, the x-coordinate is equal to 0. So let's say I have this graph and it hits the y-axis at 2. This would be the point 0, 2. And notice here that the x is equal to 0. So if I want to find a y-intercept, I just plug in x equals 0 to the function, and that's going to give me 12.3 times, we have 4.9 to the power 0. So the next thing I'm thinking of is how do I deal with that 0 exponent? But if I have something like 4.9 to the 0, that's just going to be equal to 1. So I have h of 0 equals, and we have 12.3 times 1, and that's going to tell us that h of 0 is equal to, we're going to have 12.3. So what is the value of the y-intercept is going to be 12.3. Question 21, we could use a calculator, or we could just do this in our heads. Anytime you have a fraction where everything on top and bottom is attached by multiplication, you're allowed to break this up into individual fractions. Like I could say that this is 8.8 divided by 2.2 and say this is now being multiplied by 10 to the 9 over 10 to the negative 3 like this. So I'm allowed to split a fraction up by multiplication as long as everything on top is attached by multiplication, and the same thing with the bottom. So now what I'm thinking of here is when I do 8.8 divided by 2.2, I know that's going to be equal to 4 because every answer choice has a 4 in it like this. But what I'm thinking of is if I move the decimal place 1 to the right for each of those, that's like doing 88 divided by 22, which I know is equal to 4. So this starts off as 4 times, and then I'm using this law of exponents. We have a to the b divided by a to the c is a to the b minus c. So I want to use this rule, and I'm using it here. So I'm going to have 10 to the 9 minus negative 3, which 9 minus negative 3 is 12. So I have 4 times 10 to the 12th power like this, and then that's going to match up with choice A. Question 22, we have a person diving into a pool from its edge to swim to the other side, and the table shows the depth in feet of the person from the surface of the water after X seconds. And we're told the data can be modeled by a quadratic function. So that's the million-dollar phrase right here. Which function best models the data? So we could do this question in the calculator. We're going to press stat and then go to edit here. And then we're going to type the X in the L1 column, and we're going to type the Y column or the D of X in the L2 spot. Now, once we have all the data entered in, we're going to press stats, go over to calculate, and we're going to calculate the quadratic regression. So that's over here on option 5. And we know this because they said the data can be modeled with a quadratic graph. So we're going to go ahead and just press enter all the way down through calculate. And then this is all the information we need. So now we can just write out the function here. We have y equals, and we have ax squared, but they told us a is 0.26. So we have 0.26 x squared. B is equal to minus 3.11. So we have minus 3.11 like this, and then we tack on the x. And then C is equal to 0. So I could write plus 0, but that's not needed here. I could just leave that out. And now if we go to the answer choices, this matches up with choice H. Question 23, we just have to do the algebra by adding these two expressions together. But pretend you're back in elementary school. Remember doing stuff like this. You would write everything vertically. So you would write, let's say 4, 5, 6, 1, 2, 3, you would write the terms lined up by place value, and then you would say 6 plus 3 is 9, 5 plus 2 is 7, 4 plus 1 is 5, and you would do your long addition like this. So what you could do is you have 5RT minus 3RW minus 8TW, and now I'm going to write 6RT underneath. So we're adding this, so we're in a sense doing long addition, but I'm going to write the RT term underneath this RT term. The minus 4RW, I'm going to write under the other RW term. And then the last term, the TW, the plus 2TW, is going to line up with this one. So now I could just go across. I could do negative 8 plus 2. I just combine the coefficients is negative 6. And then I just tack on the TW. I have negative 3 minus 4 is negative 7. And then I tack on the RW. And then I have 5 plus 6 is 11. And then I throw on the RT. So now just look through the answer choices. We have 11 RT minus 7 RW, and then we have minus 6 TW. That's going to match up with choice B. Question 24, we have the solutions to P of x equals 0 are x equals negative 7 and x equals positive 7. We want to know which quadratic function could represent p. So for this one, what I'm thinking of, because the language here could be a little bit confusing, but when they tell you that p of x equals 0 when x is -7 and x equals +7, it tells you that for this quadratic function, the roots or the x-intercepts are at -7 and +7. And now since all of these answer choices have x squared either minus or plus a number, I'm thinking right away that it's going to look something like this. Okay, because x squared, if it's a positive x squared, means the parabola is smiling at you. So I'm looking at the answer choices and f looks good because if we set x squared minus 49 equal to 0, this is going to factor nicely to x plus 7 times x minus 7 equals 0. And if you don't know that, this is from the formula. Let me just give ourselves a little space. I would have this nice formula here for difference of two squares. We have a squared minus b squared factors to a plus b times a minus b. So this, I would use that idea that technically 49 is 7 squared, so I'd have x squared minus 7 squared factoring to this. And now if I set each factor equal to 0, that gives me x plus 7 equals 0 and x minus 7 equals 0. And if I solve, that's going to give me a solution of x equals -7, and the second equation gives me a solution of x equals +7. So that's how I know this one here is definitely going to check out. Question 25, we have 2 points plotted, and we want to know which equation in slope-intercept form best represents the line that passes through these 2 points. So for this one here, what we could do is we could find the slope between those 2 points, and we could use the formula or we could count the rise over run. But these points are pretty far away from each other, so I might not be so confident in my ability to count that far. But if you want to do the rise over run, by all means, go ahead and do that. So this is the point -2, 6, and this is the point 1, -4. So I could call this one x1, y1, and I could call this point over here x2, y2. So if I want to find the slope, I'm doing y2 is -4 minus y1 is 6, and I'm dividing by x2 is 1 minus x1 is -2. And now we simplify here, -4 minus 6 is -10, and then 1 minus -2, this will change to 1 plus 2, is going to give us 3. So I think of the equation of a line, y equals, we have mx plus b. Our slope we just found here, so our slope is equal to -10/3. So I know this is going to start off as y equals -10/3 times x, and then plus or minus something. But notice the only answer choice that starts with -10/3 x is going to be choice D here. But if I wanted to solve for the y-intercept, there's a few ways that I could do this. One way would be to plug the point in. I could plug in xy into this equation, and I could plug in the slope. So if I plugged in here, let's say I plug in y equals -4 equals, the slope is -10/3, and I multiply by, when y is -4, x is 1, and then we have plus b. So now this works out to we have -4 equals -10/3 plus b, because I'm just multiplying by 1 here. So now I could add 10/3 to both sides like this. And now I could use a calculator for this part, or I could say 10/3 and then -4, but I'm going to write 4. Instead of 4, I'm going to call this 4 over 1, and I'm going to multiply the top and bottom by 3. So that's minus, I would have 12 over 3. And you could even check here, 12 divided by 3 would bring you right back to 4. And then if I do the subtraction here, 10 minus 12 is -2, and my denominator stays the same. So my b value would be -2/3. So notice that the equation of our line, if I tack on the b term here, our b term is -2/3, and this definitely matches with choice D. So question 26, we could do this 2 ways. First, we're going to just think about this, and then we'll check our answer in the calculator. So we have a table showing the value in dollars of a motorcycle at the end of X years. Which exponential function models this situation? Now, these 2 answer choices I could eliminate right away, because what you should notice is that the value of the motorcycle is decreasing over time, which makes sense because the moment you buy a motorcycle or a car and leave the dealership, the value of that vehicle is going to decrease. So that means that the base of your exponent can't be something bigger than 1. So when you have an exponential function like this, if you have a as some value bigger than 1, this is going to be exponential increase, okay? So, or we could say exponential growth is when the base is greater than 1. If my base is something between 0 and 1, this is going to be exponential decay, okay? Or it's essentially decreasing in value over time. So this is the situation that we need because the value is going down over time. So that's how I know it's between choices G and J. And then what I could do to determine which one's the answer is I could take a random point like 0, 9,000. So this is my X and my Y, but if I want to write this in function language, that would say V of 0 is equal to 9,000. And what this means is when we plug 0 into the answer, it should give us 9,000. So looking at it, I can see choice G is going to work because if I do V of 0, that's going to give me 9,000 times 0.9 to the 0 power. And when I raise 0.9 to the 0, that's equal to 1. So I have 9,000 times 1, which is in fact equal to 9,000. But if I were to plug in 0 to this answer choice, I would get 8,100 times 0.9 to the 0, which would give me 8,100 times 1, which would give me 8,100, which would not match the entry for 9,000. So I know this answer choice is good. Now, another way we could do this is the third time we're using this method here, is we could take this table and fill it out. So we have 0, and we're going to plug in the x values in L1, and we're going to plug the v of x or y values in L2. Now, just in case you missed that, when you want to get rid of these extra values, just press delete like this, and that'll clear out the table. So now we go to stats, calculate, and we're calculating an exponential regression. So that's option 0 on this calculator. So I press enter, and then I keep pressing enter, and this is all the data we need. So if we want to write this out ourselves, we would have y equals a is 9,000, so we write that in place here, 9,000. And then b we could write in parentheses and raise it to the x. b is 0.9. So you see right away, just using the calculator, this will just send you directly to the correct answer choice, which in this case here is choice G. So question 27, we have this quadratic equation here, and we want to know what is the positive solution to this quadratic equation. So this we could solve by factoring. So we look at this, we need two numbers that have a sum of 9, and the two numbers also need to have a product of negative 22. So the numbers you should be thinking of are positive 11 and negative 2. So how do I know that these numbers work? Well, the mental check that I go through is I take 11 and negative 2, and if I do 11 plus negative 2, that gives us 9. And if I do 11 times negative 2, that's going to give us negative 22. So these numbers do in fact check out, and then I would set each one equal to 0, each factor. So we have x plus 11 equals 0, and we have x minus 2 is equal to 0. And then subtracting 11 on both sides for this first equation gives us an x value of negative 11. And then if we add 2 on both sides to the second equation, that gives us x equals 2. But remember, we just want the positive solution. So we're going to select x equals 2 as our answer. Now, if you have the time, it really makes sense to check your answer. So I would take x squared plus 9x, and then we have minus 22. And we're going to graph this. And I'm just going to press zoom number 6 to make sure the graph is in standard form. And notice that our solution was x equals 2. And that tells us where the graph is crossing the x-axis. But we also had a root of negative 11. But notice we don't see anything. So that would be because we have to zoom this out a little bit. I would go to the window setting. And if I want to go to negative 11, that's less than negative 10. So let's say I bring my x minimum back to like negative 15. And now I could see my two roots of, we have negative 11 and positive 2. If you wanted to see the entire parabola, and I'm not talking about the entire parabola technically because it goes to infinity, but if I want to see the vertex, then I would look here and look at my table and see that the turning point is at negative 4.5, between negative 4 and negative 5. And my y values here are at negative 42. So if I make my y minimum something less than negative 10, like let's say negative 45, that would go low enough to capture the vertex now. And you could see, you get a nice clear picture here. But once again, we have roots of negative 11 and 2, but 2 is our answer because that's the positive answer. Question 28, we have to take this situation and turn it into an inequality. And one thing that's nice is every answer choice has either a less than or equal to. So they're not going to try to trip us up over correctly determining less than or greater than. So now if we look at this question, a university is going to spend at most $4,500 to buy monitors and keyboards. Each monitor costs $250 and each keyboard costs $50. And now we want to know which inequality represents all possible combinations of x, and x is the number of monitors. Okay, so I'm going to put the x next to monitors, and y is the number of keyboards. So y goes with keyboards. So right away what I'm thinking is if the monitors cost $250 each, I would do 250 times x, and that would tell us how much we spend on monitors. And then I would add the cost of keyboards. They're $50 each, so if I do 50 times y, that's how much that the university is going to spend on keyboards. And what we have here is that we want this total bill to be less than or equal to. So at most means less than or equal to. The total bill is $4,500 like this. So now we scan the answer choices here. So once again, the 250 has to belong to the x. So that's why these choices are quickly eliminated because they mixed up the price of the monitor with the price of the keyboard. And then here, it's going to be less than or equal to, because once again, at most means it could be equal to $4,500. If the bill was exactly $4,500, that would be fine because they're spending at most $4,500. So that's why we have the equal to included, and choice F is out. Definitely choice G. So question 29, we have a whole lot going on. We have a word problem, we have a scatter plot, and we have a table, but all we're looking for is which function best models the data. So this takes some of the stress off because it tells us at the end, we just need to come up with a linear function, because I'm noticing every answer choice here is a linear function. And if I look at this scatter plot, I notice right away that this is a decreasing line. Once we draw the line in, the line is going to be decreasing here. So I can see right away without even reading anything, I'm like, okay, it's probably not choice C and choice D. Well, it's definitely not choice C and choice D because these have positive slope. So these lines should go up. Okay, so these lines should be increasing. They should be going up. So I know those two choices are out. And now these two choices have the same slope. So that's fine. And then I notice here the y-intercept is all the way here at almost 100. So I know I colored it in to make it look like exactly 100. So I'm looking at this and saying, all right, A is definitely better than B because this y-intercept is way too low. It's definitely not down here at 7.3. So now let me just approach the question though to make sure that what we found is actually correct. Because if you just go through the whole test, like just blasting through every question, you could step into a lot of bear traps. Okay, so let me just read this carefully. A construction manager is monitoring the progress of the build of a house. The scatter plot and tables show the number of months since the start of the build and the percentage of the house still left to build. A linear function can be used. Okay, so we really just have to come up with an equation of a line that captures all this data. So now, once again, the method I used before is pretty reliable, but just to be safe, I'm going to enter the data from the table. So now that the data is in, we're going to press stat, we're going to go to calculate, and we're going to calculate a linear regression. So that's what they said. There's a linear relationship. So that's why we're doing a linear regression. So now borrowing this data, we have y equals our A value. If we round it to the nearest tenth is negative 13.5. We tack on the x, and then our B value to the nearest tenth is going to give us plus 97.8. So you see how this gives us the exact equation. So here you could just once again do a linear regression, but common sense will also tell you choice A. So question 30, it helps to know the difference of two perfect squares formula. When you have a squared minus b squared, this factors nicely to a plus b times a minus b. So now when we look at this question, we have f of x is x squared minus 36. Which statement is true? And the phrase that jumps out at me in every answer choice is 0 or zeros. So that tells me to take the function f of x, and we have x squared minus 36, and set the function equal to 0. And now I'm going to factor this using difference of two squares. Just know that 36 is equal to 6 to the second power. So technically this is x squared minus 6 squared, which will factor nicely to x plus 6 times x minus 6. And now we have this equal to 0, and if I want to find the roots, I would set each factor equal to 0. So I'd have x plus 6 equal to 0, and I would have x minus 6 equal to 0. And then solving this, if I subtract 6 on both sides, I get x equals negative 6. And you could even verify here, negative 6 plus 6 is 0. And then the solution to the second equation would be x equals positive 6, because 6 minus 6 would be equal to 0. So we would have two zeros here, which tells me that the first two answer choices are gone because they're saying, hey, there's only one 0. And then I know the roots are negative 6 and 6, so choice H is automatically correct. But if we look at the rest here, see how they factor this correctly. 0 equals x plus 6, x minus 6. This gives us the line that we had here. So I know that this answer choice is good. Question 31, we have f of x equals 7 minus 4x, and we want to find f of negative 5. So that just tells us plug in x equals negative 5 to the function. Now, just to make sure that you're accurate here, you're just replacing each of those x's with negative 5. So we have f of negative 5 equals 7 minus 4 times x is negative 5 in this case. So now we have f of negative 5 equals, and we're going to have 7, and we have negative 4 times negative 5 is positive 20, and then 7 plus 20 is 27. This matches choice A. Question 32, which graph best represents this equation here? So I'm thinking y equals mx plus b. This is going to be very helpful because when our line is in the form of mx plus b, we could identify the slope and the y-intercept, and that's going to help us narrow down the answer choices. So here, to get it in the form mx plus b, we're going to distribute. So we have negative 4 times x is negative 4x. We have negative 4 times 3 is negative 12, and then we tack on the minus 2. Don't get too excited here and send the negative 4 all the way through to the negative 2. You only distribute until you get to the end of the parentheses. So now this simplifies to negative 4x minus 14. So our line is negative 4x minus 14. So just looking at this, I could eliminate choices F and G. And the way I know this is that our slope is -4. And if we think of our friend here, slope guy, and sorry if slope guy traumatizes one of you. I know like slope guy like could look a little bit scary, but he's very helpful for understanding what slope tells you about a line. So when you have a positive slope, your line goes up. When you have a negative slope, your line goes down. When you have a vertical line, that's an undefined slope. And when you have a horizontal line, that's a zero slope. So slope guy will help you with that. So that's how I know F and G are out, because we have a negative slope. Our slope is -4, so our line should be dropping. So F and G are out. It's down to H and J. So now to choose the correct answer, what I would do is, let's say we have this point here at -5, 6. And on the second line, we have a clear point here at -3, 2. Because what I notice is I could say, oh, well, maybe the slopes are different, but these lines have the same slope. They both have a slope of -4. And notice the graph gets cut off here. It's like, oh no, is it this one or this one? Like I have a feeling it's H, because H looks like it's heading towards this y-intercept of -14. This line looks like it's going to hit the y-axis before -14, so I'm thinking H. So let me see if this is in fact the correct answer. And if it's not, I'll exit out and say the answer is J, but I'm pretty sure it's this one just by eyeballing it. But to be safe, I would plug x equals -5 in and y equals 6. So if I plug in here, I would have 6 equals -4 times x is -5, and we tack on our -14. So this would give us 6 equals -4 times -5 is 20, and 20 minus 14 would give us 6. So this checks out for this equation here. But if I plugged in this point to this equation, watch what happens. We would have 2 equals -4 times -3 minus 14. And this gives us 2 equals +12 minus 14. And ask yourself, is 2 equal to -2? No, this is absolutely not true, which would mean that this point, -3, 2, is not on this line here. So that's why J is out. And this is definitely our correct answer. Question 33, we have a quadratic expression, and we have to factor it, but we only have to identify one factor. And they're doing that to make it difficult to use the calculator. So here, I'm going to identify the A, B, and C value. And what I mean by that is any quadratic could be in the form of ax squared plus bx plus c. So this is just the general form of a quadratic expression. So a, b, and c represent the coefficients. So the AC method is a nice method for factoring. And what you do is you take the product of the AC terms. So we have a is 10 times c is 6. So a times c would be 60. And then your b term is -19. And then you think, what two numbers have a product of AC, or 60, and what two numbers have a sum of -19? So if we think about this, the two numbers are going to be -15 and -4. And we could double check this by adding those numbers. You get -19. And when you multiply, you're going to get 60. And then what you do with those numbers is you take the middle term and you split it. You're going to split it into -15x minus 4x, and then we tack on our plus 6. Okay, so if I wanted to go from this line back to the beginning, I would just combine -15x and -4x, and that would give me -19x. So now we do factor by grouping. So we're going to take the greatest common factor of these two terms. Between 10 and 15, the greatest common factor is 5, and between x squared and x, the greatest common factor is x. And then what would I have left in parentheses here? If I did 10x squared divided by 5x, I would have 2x left. And if I did 15x divided by 5x, I would have a 3 left. And there's a minus sign between them. So I have 2x minus 3, which we look here and we're like, oh no, that didn't show up. That just means keep going here. And now the goal is to have a matching factor of 2x minus 3 after I factor out from the second set of terms here. So now what is the greatest common factor between minus 4x and plus 6? I could go ahead and say, I'm going to say -2 here. Now, the reason why I want to factor out a -2, let's say instead I factor out a +2. This is not necessarily wrong, but it's going to delay us. I would have left in parentheses here, I would have -2x plus 3. And then notice that 2x minus 3 does not match -2x plus 3. So watch what happens instead if I were to factor out a -2. So I factor out a -2, -4x divided by -2 is +2x. And if I do 6 divided by -2, that's -3. So you see how now I have matching factors of 2x minus 3. So now in the last step here, I take out a 2x minus 3, and now I write the leftovers. The leftovers would be 5x and -2 like this. So that would be the factored form of this quadratic expression. And now when we scan the answer choices here, we can see 5x minus 2 is our solution. So question 34, more slope. The table shows the linear relationship between the distance in feet below sea level and the time in seconds traveled by the submarine. What is the rate of change, which means slope, of the distance in feet below sea level with respect to time that the submarine traveled? So in a sense, what I'm thinking of is if we're looking for the rate of change in distance with respect to time, this is acting almost as our y values, and this is acting as our x values. So what I'm thinking of, if we want to find the rate of change or the slope, I'm thinking of it as the change in y over the change in x. Or we could also say it in the form of y2 minus y1 over x2 minus x1. So what we could do here is just pick any pair of points to find the slope between them. And I'll pick the smallest numbers that we have in our list, which is 0, 18, and then 460, 604, because the other numbers just get way too big. But no matter which pair that I choose, I would still get the same answer. So here, the rate of change we're going to call m is equal to, and just think of these points as this is the point 0, 460, and then this point is the point 18, 604 like this. So we could call this x1, y1, and we could call this point x2, y2. They didn't assign variables here, so we could just call this any variable we want, so we'll use the one that comes from the slope formula. So now we have 604 minus 460, and we're dividing by 18 minus 0. Now, one thing to be careful of, because I see this all the time, please don't do something like this. I see students do stuff like 604 minus 460, and then they write divided by 18 minus 0. The problem with this, 18 minus 0. The problem with this is that you're not using parentheses before and after your division sign. So the calculator is doing 604. It's essentially doing 604 minus, and then I'll put the fraction here. So alpha y equals enter. If you didn't know that, alpha y equals enter makes a nice fraction. If I do 604 minus 460 divided by 18, you're going to see here that we get the same exact answer as this, which is not what we want. So I'm going to press alpha y equals enter. What we want to do is we want to do 604 minus 460 and divide by 18 minus 0. Let's pretend we don't know 18 minus 0 is 18. Okay. And we would get a slope of 8. This is a way more reasonable number here. Now, if you didn't want to use this fraction form trick here, the alpha y equals enter, to do it correctly the way we tried to first, we would do 604 minus 460, and then we would close the parentheses and write divided by 18 minus 0. So you can write it that way, but you just once again have to make sure to use parentheses. And notice we also get 8. So our rate of change here is equal to 8. Now, one thing before we move on that bothers me is that a lot of these math tests, and it doesn't matter which state you're in, this just seems to be the norm across a lot of algebra math tests, is that when you're finding the rate of change, they don't actually emphasize units. So one thing I want to make mention of here, because in classes like physics or other science classes, you really need to pay attention to units. So one thing that I'm noticing right away is that when I do 604 minus 460, notice that the units for the y column was feet. And the units for 18 minus 0, the entries in this column, was seconds. So if I actually write the units next to it, this tells us our slope is 8 feet per second. So what this means in the context of the question here is that the distance below sea level, that the submarine is going 8 feet per second under sea level. Question 35, which equation best represents the line shown on the grid? So we look at this here and say, all right, this is a horizontal line. And we say, oh, the x-axis is also horizontal. So it must be x equals -6. No, be careful. This is a very, very dangerous bear trap. What you want to think about for situations like this is you could either just memorize that horizontal lines are in the form of y equals k, where k is constant. And we could also say in the same breath here, that vertical lines are in the form x equals k, where k is constant. But another way to actually understand this is just pick out a few points. Like let's say I pick this point here, and I'll pick out, let's say, this point here. So this is the point -7, -6, because I go to the left 7, down 6. This is the point 2, -6. And then this over here is the point 5, -6. So look at the 3 points that I just selected. What do they all have in common? Every single one of those points, the y value is equal to -6. So everything that these points have in common is that the y value here, the y value is equal to -6, which would tell us the correct answer is choice B. Now, if we want to double check, we could go to the y equals here and write in y equals, and we have -6. And if I press graph, the graph is still out of whack from before, so I'm just going to press zoom 6, and that'll put it back to normal. And notice we have a horizontal line going through -6. So our answer, choice B here, is definitely correct. So question 36, we have an insect population that could be modeled by this function here. So why not just go to the y equals and type this in? We have 18, and in parentheses here, we have 1.3 going up to the x power. So we press this up arrow right above the division, and we tack on our x. That's our variable button here. And now when we press graph, notice we don't really see a whole lot, and that's because that this thing is starting at 18. So if I look at the table, I press second graph. Notice when I scroll back to 0 here, we're starting at 18, and this is going way, 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 way up. So I'm going to press window, and I'm going to make my y maximum 100, just so we have plenty of space above to see this exponential curve really take off. So now this information here will help us answer this question. Now right away, we could see that g of x is an increasing function. See how it's just going up as we move from left to right? This curve is going up. So the insect population should be increasing. So choices G and J are gone because they're telling us that the population decreased. And then the next thing I'm noticing is that choice F says the population increased by 13 insects each month. Well, that would be a constant rate of change. Okay, so a constant rate of change, which would tell you that this would be linear. But notice the graph, this is not a linear function. This is an exponential function, because if it was linear, it would look like a straight line like that. So that's how I know F is out, and automatically it's going to be choice H. Now, if I want a more precise way of doing this, a more technical way, what I'm thinking of is this formula here that I have A equals P times 1 plus or minus R to the power T. So anytime I have a function in this form here, this tells me exponential growth or decay. And I know that this is once again exponential because we have 1.3 to the x power. So it's reminding me of this equation here. So what we have is, in a sense, it's like P is equal to 18. And then this is a 1 plus situation, not minus, because our value of our base is greater than 1. So what we have is our R value is 0.3, and then instead of t, it's x. So it's not really like a big change here. So now what I notice is that g of x is equal to p, which is 18, times 1 plus r, 0.3, and then to the x power like this. And notice when I have r is equal to 0.3, that's the same thing as 3 over 10, which if I multiply the top and bottom by 10 gives me 30 over 100, which is equal to 30%. So now this answer choice is looking really good because our R value is the rate of increase here. So we are increasing at a rate of 30% each month. So choice H is definitely correct. So question 37, we have this line here, and we want to know which ordered pair is in the solution set of y is greater than -1/6 x minus 4. So greater than tells us to take this line here and to shade everything above. Now, a subtle detail that we also have to consider here is the fact that this is not greater than or equal to. This is just greater than. So that would tell us to take this line and turn it into a dotted line like this, because that means that any point that they give us that's on the line cannot be considered to be a solution of this inequality. So let's take a look at, let's say, -8,8. Right away, I could see that this answer is good because it's in the shaded region. So I'm going to say A is our answer, but I'm also going to check that the other answers are no good. So if we look here, 6, -5 is tempting. But remember what I said before, this is right on the line, but any point right on the line is no good because this is a strictly greater than inequality. If I wanted to verify here, like why is the point 6, -5 no good? If we plug in here, we would have y equals -5 and ask yourself, is this greater than -1/6 times 6 minus 4? And I have 6 over 6, which cancels. And this gives me -5 is greater than -1 minus 4 is -5. Is -5 greater than itself? No, this is a false statement. So that's why this answer choice is definitely not it. So let's look at 4, -6 is clearly not in the shaded region. So this is not a solution. And -2, -7 is also way out of the shaded region. So once again, this answer choice B is tempting, but it's not it. A is our best answer, once again, because it's directly in the shaded region. There's no debating whether or not it's in the shaded region. It's clearly above this line. Take a moment to read through question 38. So we have the conversion from degrees Celsius to degrees Fahrenheit can be found using a linear function. There's a linear relationship between degrees Celsius and degrees Fahrenheit. And we have a graph of that linear relationship. Y is telling us degrees Fahrenheit. X is telling us degrees Celsius. And we want to know which equation best represents this situation. So one thing that jumps out at me right away, once again, I'm using this formula, mx plus b. B is our y-intercept, and this line has a y-intercept of 32. So our b value is 32. So that tells me f and g are out, because technically after the x, we have a plus 0 in both cases, which would be a y-intercept of 0. That means the lines would start down here, not up here. So that's why those two answer choices are gone. And now to find out which answer is definitely correct, what we could do here is we could look for a point on the line. Like a point like this I don't like because it's somewhere between 72 and 80, and unless you bring a magnifying glass, that's going to be hard to see. But something like this I see is directly on one of these intersection points of the axes. So I would have the point here, let's say 40 comma and then 104 like this. So I would go ahead and find the slope between 0.32 and 40.104. So for that, we could just use a calculator. So let's go ahead and go back to the main screen. We press second mode to quit this screen. And I'm going to press alpha y equals enter. And I'm going to do the difference of the y value. So I'm going to have 104 minus 32. So I'm doing the difference of the y values divided by the difference of the x values. So I have 40 minus 0. We'll pretend we don't know 40 minus 0 is 40. And now this simplifies to 1.8. So that tells me the slope is going to be 1.8. And 1.8 is definitely not going to be 5/9 because 5/9 is between 0 and 1. So I know this one is out, but I could also say that 1.8 is the same thing as 9/5. This is equal to 1.8. So choice J is our solution. Now, one last calculator trick, like how do I get 9/5 out of that? I could just press math and then enter, and that's going to turn 1.8 into a fraction. Question 39, which graph best represents the solution set for this system of inequalities? And the first thing that jumps out at me is that these are both less than inequalities, which means that when we graph these, that they're going to be dotted lines involved. So A is out because these are two solid lines. D is out for the same reason. We have two solid lines. So it's either going to be choice B or C. And now the next idea that we want is y equals mx plus b. We want these to be in the form of mx plus b. And this shows up a lot on the STAAR Algebra 1 exam. So if there's one thing to be awesome at for this test, be really awesome at mx plus b. So we want to turn this into the form mx plus b. So I'm taking the second one here, y minus x, which is less than 3. And I'm going to add x to both sides. So now what we have is we have y is less than x plus 3. So what this is telling me is that when we have this line, we're going to shade under. Okay, so we're going to shade under like this. And now I take this equation. This one's a little bit more complicated, the algebra we have to do. But we have x plus 2y is less than negative 2. And if I want to get y by itself, first I'm going to subtract x. So I have minus x on both sides. And now x minus x is gone. We have 2y is less than negative x minus 2. And now I'm going to divide both sides by 2. But to accomplish this, I'm going to divide everything on the right side by 2. So I have y is less than, and there's an invisible 1 in front, so I would have negative 1/2 x, and then minus 2 divided by 2 is 1. So this is my second inequality, and notice it's another less than, which tells us to shade under. So I'm looking for the answer choice where both lines involved were shading under. So just looking at this, B is out. Because notice here, we have a y-intercept of negative 1, and this is the slope negative 1/2. So this represents the inequality. It should be representing the inequality y is less than negative 1/2 x minus 1, but this would tell us to shade under this line. And notice that we're shading above the line. So that's why this one's out. Choice C is good because once again, we have the line here. We have y, if this was the line, it would be y equals x plus 3, but we should have the inequality y is less than x plus 3. So notice that we're shading under this line. And we're also, for this inequality, this is y is less than negative 1/2 x minus 1. We're shading under both lines simultaneously. So this is definitely our answer choice. Now, there are some cool calculator tricks that we could do here. If we go to the apps button and we go to inequals number 7 here, I press this and I just press enter. Now when I go to the y equals, I'm going to write in, we have negative 1/2. So and let's actually make sure we go here. We have negative 1/2, and then I have x, and then minus 1. If this is bothering you like the way I wrote it, remember, you could just press alpha y equals enter, and we could write negative 1/2 like this, but the calculator would pick it up fine the way I had it written a moment ago. So you have negative 1/2 x minus 1, but it's y less than. So now I go over to this, and I had to turn the inequals feature on so I could press enter, and I could change this from equal to less than. Okay, so that's what I needed to do here. I needed to change it to less than. So now we'll just press OK. And now we'll go to the next inequality is going to be, we had x plus 3, but it was y less than x plus 3. So I write in my x plus 3, and then I'm going to change this also to less than. So I select the whole thing here, and we are going to switch this one to less than. So I press enter, OK. And now when I press graph, check it out here, it graphs everything we need. So our actual solution set is the overlapping region, and you can see it corresponds to the shaded region here in choice C. So that's definitely our answer. Now for question 40, one of the big ideas we could use is that roots and factors. So roots and factors have an opposite relationship. So this is just an important idea that shows up a lot in algebra. So roots and factors have an opposite relationship, okay? And this is something that you use in algebra and higher levels of math too. So they have an opposite relationship. And how does that help us here? Well, I look at this function and it's in factored form. So if I want to find the roots of h of x, I say, all right, the factor x plus 1, what is opposite of plus 1? Would be minus 1. So one of my roots would be x equals negative 1. And then opposite of the factor where we have x minus 3 would give us a root of x equals positive 3. So there's that opposite relationship that I'm talking about. So using that idea, what we have is choices F and H have roots at negative 1 and 3. So these are contenders, both of these answers. But G and J are out because the roots are occurring at negative 3 and 1. So these are clearly out. Now, if I want to do this without a calculator, what I could do is I could take h of x and I could expand this. I could go ahead and multiply this out. Some people call this FOIL, or you could just call it distributing because that's the more widely accepted term here using the distributive property. So we have x times x is x squared. X times negative 3 is negative 3x. And then I distribute the 1. I have 1 times x is 1x, or just x. And then I have 1 times negative 3 is minus 3. And that would give me, once I combine like terms, I would have x squared, negative 3 plus 1 is minus 2. So I have minus 2x minus 3. Now, how does that help us? Well, when I look at this equation here, we have x squared minus 2x minus 3. I'm looking at the y-intercept. And out of the remaining answer choices, I notice this one has a y-intercept over here at negative 3. So that's the y-intercept here, whereas choice H has a y-intercept. It looks like the y-intercept is occurring at negative 1.5. But what that means is when I plug in 0 to the function, I would have to get that corresponding y-intercept. So if we plug in 0 here, notice what we get. We get 0 squared minus 2 times 0 minus 3, which would be equal to minus 3. So we would need a y-intercept of minus 3. So choice F would be the answer. Now, of course, the calculator is way easier. So what we could do here also, I'm just going to go on to one of these equation parts here. So let me just clear this part out. So I'm going to get rid of this stuff here so it's not too cluttered in the picture. And I'm going to go to y3 because there's nothing happening there. And we have x plus 1 in parentheses. And then I'm going to close the parentheses and open up a new one to write x minus 3. And when we write this in here, we should get something that looks like the correct answer choice here. So I go ahead and press graph. And notice that we have a root at negative 1 and we have a root at positive 3 and we have a y-intercept down here at negative 3. So that's how I know our answer choice is good. Now, let's say this is bothering you and you're like, oh no, I don't like how this looks. If you want to reset a calculator, just press second plus, that's where the memory is. And then 7 is reset, and then 1 and 2. And now when you go to the y equals, everything is back to normal. Question 41, the first 6 terms in a geometric sequence are shown. We have a sub 1. This means the first term. Okay, so just in case you're not familiar with that notation, that means first term. The first term is negative 4. The second term, a sub 2, is negative 16. Here's our third term, fourth, fifth, and sixth. And what we're trying to do here is, using this information, which equation can be used to find the nth term in the sequence a sub n. Now, since this is a geometric sequence, we could use this formula that a sub n equals a1 times r to the n minus 1, where r is the common ratio. Now, the common ratio is really just the number that you multiply by to get from one term to the next. So notice, to get from negative 4 to negative 16, I do times 4. And then if I do times 4 again, it brings me here, here, and here. So r, in this case, is equal to 4. If I wanted to find this a fancier way, I could take any term other than the first, something like negative 16, and I divide by the term before it. Okay, so if I did negative 16 divided by negative 4, that gives me positive 4 like this. I could also take negative 64, and I could divide that by negative 16, and I also get 4. So now, another thing that just helps me get to the right answer immediately is that it's a geometric sequence which behaves in an exponential way. Okay, so I just think of this as being in the same neighborhood as an exponential function, because you see how we have r, which is a number, to some power. So that means choice A is out because -4 times n would be linear, not exponential. And then this is out because it would be quadratic if I had n to the second power. And then now we're between choices B and D, but remember, r was equal to +4, not -4. This would tell you r is -4, which doesn't match the work we just did here. So that's how I know choice D is out, and choice B would be our answer. Now, if we want to be 100% sure here, let's type this in exactly as we see it with the parentheses in place. So we have negative and then 4, and instead of n, I'm going to use to the x power like this. And I'm going to press second graph and go to the table, and notice that a sub 1, so this corresponds to x equals 1, is -4. And then we get all the values here, -16, -64, -256, and so on. Let's see, why was choice D no good? And this one I could just see right away is not going to be good because the negative is inside the parentheses with the 4. So this sequence of terms is going to be alternating from positive to negative. So if we look here, the absolute value of each y value is the same, but notice how this one goes from -4, and then a moment later it's +16, -64, but then +256. So that's why this answer choice D is no good. B is definitely our answer. Question 42, we want to know what is the solution to this equation here. So what we could do is we could send this 4 through. We're going to distribute first to get rid of that parentheses. So we're going to have 4q plus 4 times 56.5 is 226. And now we have this equal to 30q minus 112. So now the next thing we could do here is subtract 4q on both sides. We're doing minus 4q. And now this cancels on this side and we have 226 equals, and then 30 minus 4 is going to give us 26, and we tack on the q, and then we have minus 112. And now we're going to add 112 to both sides, so we have plus 112. And now for this part, we have 26q equals, and if we do the addition here, we're going to have 8 and then 3 like this. So now just divide both sides by 26, and this will tell you that q is equal to 13. Now, if we want to check our answer here, we could just press math and go up here to numeric solver, which is on option C here. We press enter, and then we're going to write the left side of the equation in. So we have 4 times, and instead of q, I'm going to use x plus 56.5. I close the parentheses, and then equation 2 is the right side, is going to be 30x, and then minus 112. This works very well for linear equations because linear equations only have one solution. And now to press OK, I'm going to press the graph button. And then x equals 0, and then we have this monstrous number here with a negative in front, and then another monster number. This is really meaning 1 times 10 to the 99. So that's a 1 with 99 zeros. So our answer should be between these two numbers because this is like really far to the left and really far to the right. I would be surprised if they made your answer 1 times 10 to the 100. That would just be cruel. So now to solve this, I'm going to press graph. And notice we get x equals 13, which matches our answer of q equals 13. Question 43, just be awesome at factoring. You should know how to factor out a greatest common factor, and you should know how to factor with difference of two perfect squares. So the greatest common factor between these two terms, right away I could see is 4. And that, if we divide each term by 4, 36 divided by 4 is 9. And then I tack on the m squared, minus 100 divided by 4 is 25. And now this fits the form of difference of two squares. We have a squared minus b squared equals a plus b times a minus b. So looking at this here, I can see that our a term, the square root of 9m squared is 3m. And then our b term, the square root of 25 would be 5. And we could just double check this. If you did a squared, you would get, once again, 9m squared. If you did b squared, 5 times 5 would give you 25. So this is going to factor nicely to, we would have 3m plus 5 times 3m minus 5. Once again, just using this formula here. And now we scan the answer choices, and you might say, oh no, our answer didn't show up, but why is it choice B? Multiplication is commutative. The order does not matter. So I could flip these two. Okay, so we could flip those two and it would match up with choice B. So question 44, there's a whole lot going on, but I'm looking at this and the question is which function best models the data? So we're going to take this and put it into the calculator because we have a table showing the net revenue in millions of dollars of a company every 3 months for 2 years. An exponential function, that's the $1 million phrase right there, can be used to model the data. So now we just go back to the main screen here. We're going to press stats. We're going to go to edit and we're going to type this in the table. Now, once again, we need an exponential regression because they said an exponential model can be used. So we go to stats. We go to calculate by scrolling to the right. And now exponential regression, we're just going to look for this here. It is at option 0. Press enter a whole bunch of times, calculate, and then here's the values we need. So now we just record everything. We have y equals a was 223.06 if we round to the nearest hundredth. Right away I could see that it's choice F, but just to see how it definitely fits, b was rounded to the hundredths place, so it stopped here. So an 8, we look to the right, it's a 9, we round up to 1.09, and this is to the x power. So using the exponential regression function of the calculator, we could determine here our answer is choice F. Question 45, which graph best represents this system of equations and its solution? So this is kind of like an unfair trick, but why not? We could go ahead and use this. We could press apps, and we're going to go to number 9 here. That says polynomial simultaneous to, I forget actually what it stands for, but that's what we need to go to. And we're going to look for the simultaneous equation solver, number 2. And what you could do is we have a 2x2 type of system because we have 2 variables here and 2 unknowns. So it's set in the correct setting here. We could just go ahead and press next by pressing the graph button. And now just type everything in, except in this case here, you would have to be able to move the y term over. So I'd have to know that that would say 2x plus y equals 6. So I'm going to go ahead and press 2, press enter. That gives me the coefficient of x plus 1y, and now is equal to 6. So just doing this puts it in the form here, puts it in standard form. And then I would have 5x, and then we have minus. So I could do minus by writing the subtraction here, pressing enter, and then 4y equals 28. And now all you have to do here is press graph to solve this. And check it out. It gives you your solution for -2. So just using the calculator, I know the solution is 4, -2. And then I look through the answer choices here, and I'm like, oh, the only one that has a solution at 4, -2 is choice B. But of course, I'm going to show you how to do this the right way, like the long way. We need to once again know y equals mx plus b. So for something like this, I take this equation. I have 2x equals 6 minus y. And the first thing I'll do is add y to both sides because I want the y on the left. It just looks nicer that way. So now I have y plus 2x equals 6, and then minus y plus y cancels. And now I'm going to do minus 2x here like this. And now I have 2x minus 2x canceling. So I have y equals -2x plus 6. So I have a y-intercept of 6, and I have a slope of -2. So looking at this, you see how we have a slope of -2 and we have a y-intercept of 6. So we're starting here at 6 and we're going down 2 over 1. So that slope of -2 is looking good for this line. So this is the line here. We could say y equals -2x and then plus 6. And now if we focus on the other line here, we have 5x minus 4y equals 28. I'm going to subtract 5x on both sides. We have minus 5x on both sides. And now from this step here, we have 5x minus 5x canceling. Minus 4y equals minus 5x plus 28. And now divide both sides by -4. So divide everything by -4. And you got y equals a negative over a negative is a positive. So I have 5/4 x. And then 28 over -4 is -7. And if we look here, see how we're starting at -7. That's our y-intercept for our second line. And we should be going up 5 over 4. So let's count. We go up 1, 2, 3, 4, 5 over 1, 2, 3, 4. So you see how this slope and y-intercept, so this line here is matching to what we have in our equation form here. So we have 5/4 x -7. So this one here truly captures it. If you want to see why the wrong answers are wrong, like right away I could see, all right, this line has a y-intercept of 7, not -7. So that's why this answer choice A is out. C is out because once again, we have a y-intercept of 7, but neither of these lines have a y-intercept of 7. And in this one, the y-intercepts are correct. However, for this one, notice that we have a y-intercept of 6, but the slope, the m value is +2, not -2. So that's why D is out. And that's why here, choice B is definitely our answer. Question 46, know how to factor. We need two numbers that have a sum of 2 and a product of -15. So this is really just a game in mental math here. So k of x equals, you should have x plus 5 times x minus 3. How do I know that this is good? Well, I'm just thinking about those two numbers. 5 times -3 is -15, and also 5 plus -3, when I find the sum of those two numbers, I get +2, which matches the middle. So x plus 5, x minus 3 corresponds to choice H. But once again, we get a calculator for this test. So we could go to the y equals, we could type in the question, and we could type in all the answers. So now that we have everything typed in, remember the question here, x squared plus 2x minus 15, that's the original function, which we wrote in the blue column, or in the blue row for y1. And the correct answer, x plus 5, x minus 3, is in pink. So the blue and the pink should overlap once we press graph. So we have the blue, and notice the blue and the pink overlapped here. So our answer is definitely good. Question 47, which graph best represents part of a quadratic function with a domain of all real numbers less than -4? Now just know that domain refers to the x values. So if we're looking for a domain of all real numbers less than -4, we're looking for a graph that only occurs for x's less than -4. So what I'm thinking of, like how do I put this in words so I know what to look for? If my function has a domain of x is less than -4, that means that the graph occurs to the left of x equals -4. Okay, so that's something to be on the lookout for. The graph has to occur to the left of x equals -4. So when I'm imagining a graph here, so here's our graph. Here's the line x equals -4. It's a vertical line. We only need a graph, or well, we're looking for a graph that only occurs in this space. So A is out because notice that A goes all the way up to x equals 0. So this would have a domain of x is less than 0 because you see after -4, it enters this space. So the graph is occurring in this space where we don't want it to. So this answer choice is out. B is out because this would be a domain. Notice we have -4 over here, but this would be a domain of x is greater than -4. So this would be correct if they said domain of all real numbers greater than -4, then B would be correct. So we don't want it to occur in this space. We want it to occur to the left of -4 on the x-axis. So now we look at choice C. Choice C is good because here's x equals -4, and the graph is occurring to the left of x equals -4. There is nothing going on to the right of -4, so that's why this answer choice is good. This answer choice is no good because the domain here would be x is greater than 0. Since the graph begins here at the point 0, -4, and notice it goes to the right, the domain would be all x values greater than 0. There is nothing going on to the left of -4 here. So choice C is definitely our answer. Question 48, we have the graph of the line passes through these 2 points. We want to know what is the slope of the line. So once again, we have to know slope. So we have y2 minus y1 over x2 minus x1, where this point here we could call x1 y1, and this point here we could call x2 y2. So now just plug into the slope formula. You have 8 minus 1, that's y2 minus y1, divided by x2 is 5 minus x1 is -3. And now this works out to 8 minus 1 is 7 over 5 minus -3 changes to 5 plus 3, which is 8. So 7/8, choice G. Question 49, we have a mail carrier delivering mail on one of 2 different routes. They have a morning route and they have an afternoon route. And each workday, the mail carrier is assigned one of these 2 routes. So last month, the mail carrier delivered mail on the morning route. So let's call the morning route X. So they delivered on the morning route 16 times. And the afternoon route we'll call Y. So afternoon we'll call Y 12 times for a total distance of 141 miles. So I'm going to write an equation for this. I'm going to say here 16x, because if the morning route is a distance of x, we'll say 16 times x is how far they went along the morning route over those 16 occurrences. So here we have 16x plus they did the afternoon route 12 times. And that was a total distance of 141 miles. And now this month, the mail carrier delivered mail on the morning route. So the morning is once again still x, but they did it 10 times, so that's 10x. And then they did the afternoon route, which is still y. So they did the afternoon route y 15 times. So that's plus 15y, and this is equal to 123.75. And we want to know what is the distance of the morning route. Once again, the morning route is x, so we're solving for x here. So for this one, there's no point in suffering, so we might as well just press apps and go to number 9 here, the simultaneous equation solver, and we're going to solve this system of equations here. So the simultaneous one is number 2, and we just type this in. We have a 2 by 2. We have 2 equations with 2 unknown variables. We press graph to go next, and we're going to have 16x plus 12y, so I'm going to put a 12 in place, press enter, and then we have 141. And now we go on next to the next row, we have 10x, and now we're going to change this to plus 15y, and this is equal to 123.75. Okay, and then now to work this out, we just press graph to solve it, And here are our solutions. So remember, x was our morning route, so x equals 21 over 4. And if we do the division here, 21 divided by 4 is 5, and there's a remainder of 1, so this is the same thing as 5.25. Choice A is our answer. Now, if you want to see how to do this by hand, not just using the calculator, we could use elimination here. And since our goal is to find the distance of the morning route, we were looking for x, I'm going to choose to eliminate y. And this one is not particularly nice because the numbers are big, so I want to make this smaller instead of multiplying by whole numbers bigger than 1. So what we have here is I would want to divide each of these things by 4. So the top equation, I'm going to multiply across by 1/4. And that's going to give us, if we did 1/4 times 16x, that's going to give us 4x. We're essentially just doing 16 divided by 4. And then we have plus 12 times 1/4 is 3, so we have 3y equals, and if I do 141 times 1/4, or 141 divided by 4, that's going to give us, we're going to have 35.25. So we have 35.25. But you could definitely just check that with the calculator, do 141 divided by 4. And now here, the goal is, once again, to get y to eliminate. So I somehow want to wind up with a minus 3y. So how could I take 15y and turn it into minus 3y? I could divide everything by negative 5. But dividing by negative 5 is the same thing as multiplying by negative 1/5. So if I do 10x times negative 1/5, I'm really in my head just doing 10 divided by negative 5, which is negative 2. So I'd have negative 2x. And if I did negative 1/5 times 15y, that gives me negative 3y. And now equals, if I do 123.75 times negative 1/5, that's going to give me negative 24.75 like this. So now I'm ready to add this resulting system together. I have 4x plus negative 2x is 2x. 3y plus negative 2y cancels, it eliminates. And now this is equal to, I have 5 minus 5 is 0. I'll just go ahead and do the long subtraction here. So we borrow to get a 4. We put a 1 here. 12 minus 7 is 5. And now we have 4 minus 4 is 0, and 3 minus 2 is 1. So 2x equals 1050. Divide both sides by 2, and x is equal to 5.25, which still gives you the same answer here. Once again, the calculator is way easier, but it is an algebra test. We should definitely know some algebra here. This would be the technical way to do it. Question 50, we have quadratic functions p and q graphed on the grid, and the graph of p was transformed to create the graph of q. Which function best represents the graph of q? Now, it's good practice to try this question without a calculator. So when I look at the graph of p, I could say that p of x is equal to x squared, because this thing here is going through the origin, and all of these points here, look at the point, we have 1, 1, we have the point 2, 4. So I'll write some of these out. We have 1, 1, we have 2, 4, we also have 3, 9. That these points, to get the x and the y's, you're just taking the y values, and the y values are simply the x values squared. So notice 1 squared is 1, 2 squared is 4, 3 squared is 9. So that's how I'm doing this part in my head. But if you want to see the very technical way to do this, to get from the graph of p to the graph of q, you might be able to see it, but the first thing that you're doing, and let's change colors here. You're taking this graph of p and you're flipping it over the x-axis. You're reflecting it. So notice here that if I were to reflect it over the x-axis, it would look something like this. So it would bring us down here like this. So I'm just going to do my best to sketch this neatly. So here is the first transformation, which is a reflection over the x-axis. And you might recognize this. This is the graph of negative x squared because it's a frowning parabola. It has a negative in front like this. Okay, so that's taking x squared. And the first thing we're doing is reflecting it. But now how do I get the red graph to move directly on top of q? I would have to shift it up 2 units. So the last transformation to do to get to q would be to shift this up 2 units. And all I have to do is add a plus 2 at the end of negative x squared. And this would match up with choice J. So this is the very technical way to do this. But if you want the easy way to do this, once again, just go through all the answer choices. We're going to press second mode to get off that screen. And I'm going to clear out all this other stuff. And we could just type in our answer choice here of negative x squared plus 2. So we'll go back to y1 here. And we're going to write in, we have negative and then x squared. And then we type in our plus 2. And notice that this matches the graph that we want, the graph of q. I'm going to press zoom 6 here so this goes back to normal. But notice that our graph here matches. For question 51, if we really don't feel like doing any work, we could press math, go up to numeric solver, and we could just type this stuff in. We have 2 times 40 minus 5y, but I'm going to put an x. The calculator, well, it doesn't matter which variable you use. It's just we're going to have to say y equals when we're all done. So we have on the right side, we have 10y, so we're going to put x, and then plus 5 times, we have 1 minus y, but once again, we're going to put x. Close the parentheses, we press graph, And then we could solve this here and just press graph to solve it. And we have a solution of x equals 5. So choice C would be our answer. But once again, I want to solve this by hand because this is an algebra test. And if we do this without actually doing algebra, it's like kind of a letdown. So 2 times 40 is 80. And then we have 2 times minus 5y is minus 10y. And this equals, we have 10y plus 5 times 1 is 5. And 5 times minus y is minus 5y. So the first thing I would do is combine like terms. I have 10y minus 5y, which I just combine the coefficients. 10 minus 5 is 5, so I have 5y. The plus 5 just tags along, and now I have 80 minus 10y. And now I'm used to the variables on the left, but in this case, I'd actually want to add 10y to both sides because I'd rather work with all positive numbers here. So now minus 10y plus 10y cancels. I have 80 equals 5y plus 10y is 15y, and then we have our plus 5. And now to solve for y, I'm going to get the 5 out of the way. That plus 5, I'm going to subtract. So now on this side, 5 minus 5 is gone. And we have 80 minus 5 is 75 equals 15y. So to solve for y, just divide both sides by 15 because that 15 is attached by multiplication and the opposite of multiplication is division. So now y equals 75 over 15 is in fact 5. So choice C is good. Question 52, we have the initial value of a home is 200,000. The value of the home will increase at a rate of 6% each year. Which graph best models this situation? So what I'm thinking of is this formula here. We have A equals P times 1 plus R to the T power. And I'm automatically going with plus because the value of the home is increasing. So here, the principal value is the initial value of the home, which is 200,000. R is the interest rate. So if R is 6%, as a decimal, that's going to be 0.06, which we could find by turning this percent into the fraction 6 over 100. And then we could write it as a decimal. If you don't know how to do that, just write 6 divided by 100 in your calculator, and it will write 0.06. So now if we plug into the formula, this tells us that we have A equals P is 200,000. So we have 200,000 times 1 plus 0.06 to the power T. But notice all of these graphs are in terms of X and Y. So now when I simplify this, I'm just going to say y equals 200,000. So I'm just going to make sure I write the correct amount of zeros. And we have 1.06 to the x power. Now, just knowing what I know about graphs, I could see this right away and say, all right, these choices are out because they start at 100,000. And I know that when I plug in x equals 0, if I were to plug in 0 here for x, 1.06 to the 0 power is 1. So I'd have 200,000 times 1, which would tell me y, when x is 0, has to be 200,000. And notice that the contending answer choices do start correctly at 200,000. But I know h is no good because this rate of growth is way too fast. We have a 6% rate of growth each year. This is going within 5 years above 900,000. That is way too fast for a 6% growth rate here. So F is the most reasonable, but we will check our answer with the calculator. So to check our work, we'll press second mode to quit this, and we're going to go to the y equals here, and we're going to type in that equation we just found, 200,000, and then we have 1.06 going up to the x power. And one thing I'd pay attention to here, so once we press graph, you're going to notice we're not going to see a thing. And the reason being is that the x-axis is counting by 5s and it's going up to 25. So my x maximum would have to go up to 25. And then if we look at our y column here, notice that the y values are going up to 900,000. So you know what, I'll just bump this up here to 1,000,000. So we have 1, and then I have to put 6 zeros. So that's 3 zeros and now another 3. So that when I press graph here, you see how this is a way more reasonable rate of growth here. And then if I look at the table, so let's say I go here and I look at the table, when I get to 5, notice I'm at 267,643, which is definitely reasonable for what we have here. But notice here that at 5, it's way over 1,000,000. So that's another reason why this answer is definitely out. And we can see here at like 15 years, we should be at about 500,000. And then sure enough, at 15 years, we're a little bit under 500,000. If you want another fancy trick, you could press second window and notice the table is counting by 5s. We could start our table at 0 and then delta table, we could switch to 5 so that when we press second graph, notice that it's counting by 5s and it's giving us the values that we need. We can see here at 25 years, we're between 8 and 900,000. And sure enough, at 25 years, we are between 8 and 900,000. So this graph here is definitely our best option. Question 53, we have a coach has 96 golf balls for the school's golf team, and the coach will give each player 8 golf balls. and the graph shows the linear relationship between y, the number of golf balls remaining for the team, and x, the number of players on the team. So here we have the actual question. The coach will use no more than 6 players on the school's golf team. Which set best represents the range of the function for this situation? Remember, the range is the possible y values. So here we're starting off, the coach has 96 golf balls. The coach is using 6 players and he's giving each of them 8 golf balls. So we're going from a y value of 96 and our lowest y value is stopping here at 48. So the range has to go from 96 to 48. And right away looking at this, I could see the only answer choice that works is choice C, that we have 96. And if we keep subtracting 8, you see when we do 96 minus 8, we're down here at 88. And if we keep subtracting 8, we have 80, 72, minus 8 is 64, minus another 8 is 56, and then finally minus 8 one more time is 48. Okay, but this would account for either no players out there, 1, 2, 3, 4, 5, 6 players out there. So this one is good. These answer choices here are no good. This would refer to the domain, so that's why this one's no good. Choice B is no good here because this one is just the most off. 8, 9, 10, 11, 12. I know they're just counting by 1 starting at 8. So I don't really know what's going on for choice B. And choice A is like the next most reasonable answer choice. We're starting at 8. But in this case here, it looks like they are subtracting by 12 each time. Okay, so they're subtracting by too much. And this one is no good. So definitely choice C. Question 54, our last question. We have a linear function k. It has a 0 of -2 and a y-intercept of 6. Which graph best represents k? Now just know a 0 of -2 has the same meaning as an x-intercept of -2. So we need something that crosses the x-axis at -2. And I can see right away, this has an x-intercept of 3, not -2. So F is out. This one has an x-intercept of 6. So this one is also out. This one has an x-intercept of -2, so it's a contender. And this one has an x-intercept of -6. It's automatically out. So G is definitely the answer. But just to verify for sure, the y-intercept is 6. And check it out. This crosses the y-axis at 6. So this is definitely our answer.